Alright, so we're going to take partial fraction decomposition one step further. So we're going to compare a linear with what's called a repeat linear fraction here. So my denominator, we have two different fractions. If we were to set this up like we did today in class or on Monday in class, we would say, okay, we've got my original fraction, and we're going to set that equal to each piece. So we take each factor and we put our variable on top, and then we would go through and solve it. So I'm going to leave that one there. If you would like to go through and do it, you can. I wanted to show you the difference. If we do that same process, we could think of x minus 1 cubed as the same thing as x minus 1 3 times. So your factors are x minus 1, x minus 1, and x minus 1. Well, if we were to do that, if we were to take my original, just like we did yesterday, and we split that up, x minus 1 plus x minus 1 plus x minus 1, and we put a, b, and c. If we think about what the goal is, we're trying to take this fraction and unsimplify it. So if we were to take my expanded fraction and try and simplify it, we're adding fractions together, we would need to get a common denominator. How it's written, we already have a common denominator. If we pull these together, we're going to get a plus b plus c over x minus 1. That is not what we had in the denominator of my original. So that tells me that I've got to do something special. And so anytime we have a repeat factor, which here we have it being repeated 3 times, we've got to list every degree leading up to how many times it's been repeated. So my degree is 3, so I need to have a degree of 1, a degree of 2, and a degree of 3, so that when we look at this as a whole, my common denominator is in fact x minus 1 to the 3rd power. So now we can go through with this, and it actually makes it a little bit easier if you actually think about what you're multiplying by. So we want to clear denominators. We're going to multiply this entire equation by x minus 1 cubed, and remember that's going to carry through to every fraction. So on my left side we just have 2x. We've got a times x minus 1 cubed, but there's already an x minus 1 in my denominator, so you don't have to write this out, but sometimes it helps if you just write down exactly what you're doing. Then the b is going to be multiplied by x minus 1 cubed over x minus 1 squared, and then let me slide this over. C is going to be multiplied by the same thing, x minus 1 cubed over x minus 1 squared. Now if you go through and you simplify, we've got one set of x minus 1's here, 3 in the top. This is the hardest part. If there's going to be mistakes, this is where people usually struggle. So we've got 3 of them on the top, 1 on the bottom. That tells me I can cancel. We've got 2 left on the top. So it's just a times x minus 1 squared plus b. We've got 3 here, 2 on the bottom, so now we just have x minus 1 left, and then c, we've got x minus 1, oh, that should have been a cube, sorry, 3 on the bottom, 3 on the top. We just have c left over, so that makes it nice. Bring down your 2x. Then if we go through the same process from yesterday, the only thing you have to be careful with, the only new part, is that when we're distributing the a through, we're distributing it to x minus 1 times x minus 1. That's what this is represented. So if we FOIL that out, we're going to get a times x squared. This will give me minus 2x, so minus 2ax plus 2a. That comes from FOILing this out and distributing a through. Distribute the b, so bx minus b plus c. Remember, from here is where we create our system. So we look at all of our x squareds. Well, we have an a x squared, and then we look for our x squareds on the left. There's none. So we know a has to be 0. Then I go down, we look for all of our x's. So we've got negative 2a plus 1b. There's no c's. Well, and that has to equal my x's on the left. So that's got to equal 2. Then I'm going to take my constants. So we've got 2a, whoops, I forgot one, minus b plus c. That has to equal the constants on the left, which was none. Then you can do one of two things. You can solve this on a calculator, but if I already know a is 0, if I plug this in, that tells me b is 2. If I plug in 0 minus 2 plus c is 0, that tells me c is 2. So now remember, this is not your final answer. You have to go back and create your fractions, but you are pretty much there. So we go back up. And I'm going to go back up to the original. Instead of writing an a, I'm going to put a 0, which really that just goes away. Instead of writing a b, I'm going to put a 2. And instead of my c, I'm going to also put a 2. So this would be your 100% final answer.